So this video is going to be on Chapter 3 of Geometry. It's going to cover 3.1 through 3.4. This chapter covers constructions as well as some great new vocab and conjectures. By the end of this video, you should know what bisectors are and what they can be used for in geometry. So your basic tools for construction are a compass, which looks like this. You should probably have one. A straight edge, which is really anything that can be used to draw a straight line when you draw up against it, and patty papers, which are the same thing as tracing paper, and they can be really useful in constructing. I'm not going to cover the actual steps of constructions, but if you do have trouble with them, there are many great videos out there that do cover that. So, a segment bisector is a line that intersects a segment at the halfway mark so that each part is congruent. You can remember that because bi means two, so two equal parts. A perpendicular bisector is very similar. It's a line that goes through the segment at the halfway point, but it does so at a right angle. So we get something like this. Okay, so we're going to begin a conjecture list, and they're always going to be in purple, and they're going to be super useful to know. So the perpendicular bisector conjecture, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So let's see here. If a point is right here on the perpendicular bisector, then the distance from here to here and the distance from here to here is going to be equal. So the converse of the perpendicular bisector conjecture simply states it in reverse. If a point is equally distant from the endpoints of a segment, then it is on the perpendicular bisector of the segment, as we can see here. So section 3.3 has to do with constructing perpendiculars. So we have another conjecture here. The shortest distance conjecture, which states that if you have a line and a point, then the shortest distance from a point to a line is measured along the perpendicular segment from the point to the line. So if we have a line and a point here, then the shortest distance is going to be right here, this perpendicular segment from the point to the line. As you can see, any other segment from the point to the line is going to be longer than the perpendicular one. Okay, so section 3.4 covers angle bisectors. So an angle bisector is a line that splits an angle into two halves that are congruent or equal. So if we have our angle here, then the bisector, and let's say it's 48 degrees. Then the bisector is going to go right here, and it's going to split this into two angles that are each 24 degrees. So now we have two more conjectures. So there's the angle bisector conjecture, which states that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So say we have this point right here, which is on the bisector. The distance from here to here and the distance from here to here are going to be equal. And as we know, these are the perpendicular segments from the line to the point, because those are the shortest distances. So this next conjecture is a little bit unrelated, but it's still really, really important to know. So it's the equilateral triangle conjecture, which says that the measure of each angle of an equilateral triangle is 60 degrees. So this is really important because they're all equal. So equilateral triangles are also equiangular.